Imagine your support bot is under a traffic spike, and someone asks about your refund policy. The retrieval call is still running against the vector store, but the generation timeout fires first, so the model answers anyway, with no context at all. It doesn't say, "I don't know." It writes a confident, fluent, wrong policy, citations and all, and ships it. No error, no red log line, no exception thrown anywhere. Just a wrong answer wearing a right one's clothes. Here's the part that should worry you. Retrieval and generation don't share a clock. They're two separate calls, on two separate timers, that just happen to run near each other, under load. A traffic spike, a slow index, a cold cache. Those timers slip apart, and whichever one wins the race decides what the model actually sees. Sometimes generation wins and the model answers on nothing. Sometimes retrieval wins too easily. It hands back a cached result that's real, just old, and the model answers on the wrong thing instead of nothing. Either way, same failure. Confident, fluent, and completely disconnected from what's true right now. By the end of this, you'll know exactly where that race happens and the 3 things that catch it before your users do. So, 4 things. Why retrieval and generation run on separate clocks in the first place. What happens when generation's clock wins? What happens when retrieval's clock wins, but hands over stale data? And the fix that catches both. Here's the architecture nobody draws on the whiteboard. A RAG call is really 2 calls. Fetch the chunks, then generate the answer. Most pipelines run them as independent operations, each with its own timeout. Retrieval isn't some fast footnote either. It typically eats around 40% of total end-to-end latency in a RAG request, and close to half of time to first token. So, whoever set the generation timeout picked a number to hit a latency target. They almost certainly didn't check it against how long retrieval actually takes at the tail. Those 2 numbers live in different config files, owned by different people. Under COM load, a vector index can answer in single-digit milliseconds at the 99th percentile. Under a real burst, cold cache. Index rebuild a noisy neighbor, that tail stretches, and nothing forces the generation timeout to stretch with it. One production catching system reported up to 4x faster time to first token and more than double the throughput just from catching retrieval properly. That's how much slack a naive, uncatched setup was leaving on the table, and this is why retrieval issues dominate. Analyses of production RAG failures put the number north of 90% retrieval side, not the model. The LM's fine. The clock feeding it isn't. No 2 clocks, 2 owners. No shared contract. That's the setup. Now watch what happens when they actually race. First, failure mode. Generation's clock wins. The orchestrator hits its timeout. Retrieval hasn't returned yet, and by design, it moves on without waiting. The reporting on this puts it plainly. When retrieval completes after the generation timeout fires, the system generates a response without retrieved context. Not an error, a response. So the model falls back to whatever's in its own parametric memory. It dresses that up in the same tone and format as a grounded answer, and nothing downstream can tell the difference. This is the part that makes it hard to catch. It's non-deterministic. It depends on load, network latency, and cache state at that exact moment. The same query can succeed at 2 p.m. and silently fail at 2 p.m. during a traffic spike. So your evil suite, run on a quiet afternoon against a warm cache, will never see this. It only shows up under the conditions you didn't test, which is exactly when your real users are hitting it hardest. That's failure mode 1. Too slow, so it answers on nothing. Second failure mode is the sneakier one, because retrieval doesn't fail slow this time. It succeeds fast with the wrong thing. A caching layer sits in front of the vector store for latency. Someone updates the underlying docs. The cache doesn't know that happened, so it keeps serving the old top K chunks for anything close to a popular query. One write-up of this exact incident called it the silent liar problem. The bot kept answering with last month's policy, complete with citations, long after the real policy change. Nothing was down. Nothing errored. The system was working exactly as built, just answering questions about a document that no longer existed. It surfaced the boring way. A slow climb in support tickets from people getting told something that used to be true. Well, nobody paged for it, because nothing paged. Same shape as failure mode 1. Confident, fluent, wrong. Just arriving from the opposite direction. Too fast, with data that's gone stale, instead of too slow with no data at all. So, here's what actually catches both directions of this race, and it's not add more timeout padding. First, make the race visible. Trace 3 explicit timestamps on every request. When retrieval starts, when it completes, when generation starts. Track the distribution of that retrieval to generation gap, and alert when its shape shifts, not just when it reaches one fixed number. Second, set your generation timeout against measured P99 retrieval latency, not a guess. And when retrieval genuinely doesn't make it in time, don't let generation quietly run on empty. Return insufficient context and say so. Third, kill the stale cache path at the key. Version cache keys off a hash of the underlying document, not a fixed TTL. So, an update invalidates instantly, instead of waiting on a clock that was never tracking freshness in the first place. Cut any one of those 3, and one of the 2 failure modes reopens. Ship all 3, and the race stops being invisible, because now something actually tells you when it happened. That's the difference between a timeout that hides the race and a timeout that catches it. If you're shipping this Monday, add the 3 timestamps. Retrieval start, retrieval end. Generation start to your existing trace. That's the cheapest step, and it's the one that makes everything else possible. Then pull your actual P99 retrieval latency from production traffic, not a staging benchmark, and check it against your generation timeout. If you don't know that number, you don't know if you're racing. Move your retrieval cache to content hash keys instead of TL only. It's a small change, and it closes the entire stale cache failure mode on its own and add one explicit fallback. If retrieval didn't complete in time, the model says so instead of answering anyway. That confident wrong answer shape isn't unique to RAG either. Next time, why agents report a task as done when it isn't, and how to catch a false success before it ships.